you get into Mike's, a lot of the stuff that I'm going to be laying in this workshop is going to also be laying into what Mike has talked about, because I think there is a general consensus that, hey, we're moving toward this model of the internet that's a projection of our current internet, and that we have basically lots of agents working in the background for us in ways that we're not using today. Real quick, so about me and how I got involved with this stuff. I chair a number of sort of open organizations. So aside from helping the Wonderful AI Alliance, I chair the technical steering committee at Decentralized Identity Foundation, so we talk a lot about decentralized identity there. There's a workshop that we also host at the Computer History Museum. I run that as well. Lead a number of initiatives in trusted AI agents, and am also the CEO of a company that's focused on policy for AI agents, which is called Agent Overlay. And when we talk about markets, Mike had a great slide about there's sort of tangible properties of markets and intangible goods, and we want to be able to trade both. I think it's easier, and we were discussing a few weeks ago, like, what do we start off with if we start thinking about marketplaces and trading? There's like so many different types of things we got to consider, right? You have to consider value, you have to consider how you price. But pretty easy, good starting point, the canonical playground starting point we realized was probably just booking time on a calendar or setting up a meeting invite, right? You go to an event like here and you need to connect with each other, and the first thing you're going to say is, hey, can I book some time on your calendar at some point after a conversation? And so how does that actually work, especially if you start thinking about it at scale? So we're going to try to think about what are the problems that we need to discuss to work on for trading time with agents. And there's a couple things we needed to be thinking about. It's going to be open source. We're going to be able to work on it together. There is code, but it's also lots of discussion, because the thing is to actually build a market that it's possible and works, especially when you consider open principles, is very hard. We're going to consider a few principles. First, any calendar agent can talk to another calendar agent. So that means that across infrastructure, that if you're hosting your calendar agent in Google and somebody else is hosting it in Amazon, and your calendar agent is part of one platform, it can talk to platforms, another calendar agent, without concern. So that's one thing we have to think about. A lot of times you'll see demos where everybody's throwing things into their own application infrastructure, and that's great for multi-agent systems that deal with like multi-tenancy, where you're dealing with single platforms. But what we really want to get when we're talking about this connection is across infrastructures, across players. That's a really hard thing to do. We want it to be able to be run from anywhere. So who has heard of the term like sovereign AI? Who knows what that means? All right, who wants to give a shot at trying to tell what sovereign AI means? Independent. Yeah, that's a good way to put it. It's independent. So sovereign AI means that we want anybody to be able to run it wherever they want to run it. And if you want to run your own models locally, you can. If you want to use some providers' models, you can. But we want to give the flexibility of deployment wherever it is. And you actually see this a lot with countries right now. They're trying to think about how do we protect our ability to use our citizens with AI, right? So if you're a large country and you're thinking about countries like, or using just OpenAI for your infrastructure at scale, this becomes quite problematic. So you see like Switzerland just launched their own LLM. There's a number of other companies that are going to be supporting LLMs for their own citizens. This concept of sovereign AI to get their own independence. Another thing our principles we must consider is it must scale to the volume of the current web, if not larger. I think the projections, in my personal opinion, is that we're going to get far more volume with the Agentic Web than we have with the current web. And so we need to be able to consider what are the mechanics that we need to be thinking about as we're starting to scale the Agentic Web. And it should work in the interest of you as users, right? So you'll see with partly sovereign AI and this concept of personal AI, how do we think about AI that's working for us, not against us, right? If you're using an Amazon agent, then Amazon agent has an incentive that might not be aligned with you as an individual. And so there's a lot of folks working on how do we think about the individual in the process of building AI systems. So sovereign AI infrastructure means you can run it anywhere, on your computer, locally, wherever. And we have lots to learn and continue. So we're going to talk about a couple things, or a lot of things actually. Agentic identity, decentralized identifiers, delegation. Who has heard of the topic of delegation? Curious of hands. 1, 2, 3. Okay, 3 people. So delegation is a really important topic. NCP registries, authorization, and policy as code. So we have a ton of topics to discover. MCP and A2A gateways, and we're going to use Context Forge, which is an AI Alliance project, or an IBM AI Alliance project. And then we're going to talk about just general protocols and trust boundaries. So At any point, if anybody has any questions, this is supposed to be sort of interactive as well, so please ask questions. So let's start off with the scenario we're trying to accomplish right now, which is we have calendar agents. Everybody here has their own calendar agents. We want to connect them, right? That's a simple question that we're trying to figure out. How do we connect them? And as we start to scale them, we have to connect lots of them. So it's one thing to say, hey, I'm going to connect your agent to my agent. It's another thing to say, I'm going to connect my agent to everybody else's agents on this entire network. And we have to think about things when we start to scale, like what happens if somebody's a bad actor in this? So when you start to think about scaling agents, you also have to think about, I don't necessarily trust every single person on this network to talk to my agent, or that they should be able to book a calendar invite. So this becomes challenging, because how do you build trust? And trust is probably one of the most fundamental things we need to figure out to be able to actually run agents at scale. Because if you talk and look at where industry is moving right now, trust is the basic challenge that we're trying to solve. And so when you start to think about the volume that we're considering, it's not just within an infrastructure, which we call the intranet. We also want the internet of agents, right? And so that's kind of what we're trying to work for, but then all these trust considerations become important. So we're going to talk about trust a lot, and trust comes with security. So a lot of folks have asked, what is an AI agent? Right? And there's going to be different interpretations, but the most simple models tend to be the best ones. And if you look at Anthropic, they've provided a model which is based on a lot of research that has done similar models. I think this is the most simple model of an agent, which is you literally have a feedback loop where the agent is taking in sensory data, right? And it's replaying actions with those sensory data and updating its sort of objectives based on that, right? So you have, it's open-ended, it's difficult to predict, it's non-deterministic. But if somebody asks you, what is an AI agent? Like, this is probably the easiest description of an AI agent. And you'll notice here there's a human, and we'll talk about that in a moment. But the human's important because sometimes the agents are acting autonomously without necessarily on behalf of a human. Sometimes they might be working on behalf of a human or organization, and we need to discuss both models. Who's using like a Cursor or a Claude for coding here? All right, and we did this poll yesterday, actually, at the unconference. Who does YOLO mode? Okay, so who's like doing it like on a scale of 1 to 5? Where do you sit in that volume? So this is basically this concept of, hey, agents, they go from L1s to L5s in terms of autonomy, and you need to remember that users do this differently. So if you go to organizations, you start to ask them, how are you using your AI agents today? You'll find that some people prefer going YOLO modes, some people prefer going it completely as an operator, and it's going to depend on the user, but we need to be able to think about the user experience from all those perspectives, right? Because it kind of, how you modify the process changes by the amount of interaction a user will have. And so AI agents, they have these tools, they have the memory, they have models like LLMs, and when we start to combine them, we get to this section where we kind of have network of agents, right? So this is, who has done multi-agent stuff here? Okay, one, not that many people. So if you're using a single agent, right, you can just build one agent, and that's kind of one scenario. But then you have these scenarios where you have swarms of agents or supervisor agents. So you can see here we have single agents, we have network of agents, supervisor agents, hierarchical. And so you'll see different procedures around how you go and construct these agents. Sometimes it's over human oversight. So if you have who's NAN or some of those tools where you connect the agents together over a visual sort of view, right? So that's like drag and drop. And then there's sometimes where you let the agents figure themselves out, and it's autonomous, and they're actually self-organizing themselves. That's more like swarm behavior. So it depends on your procedures that you want, but all of these need to be thought about when we're thinking about trust and when we're thinking about security, when we're thinking about the usefulness, costs, all these various concerns. And I think this is where I think this model is where you can kind of look and see where are the main areas of challenge as you start to increase value. So the bottom layer is AI. That's kind of you prompting to an LLM, getting it back. Once you start to enable tools, you get to agents, you get more and more value. The challenge is that as you start to enable these agents, you get more requirements for trust infrastructure because even though they're capturing more value, they also have lower control. Right? And so as we start to increase the size of the agency to being multi-agent systems and then eventually the Agentic Web, we're moving outside of our trust boundary into other people's trust boundaries. Right? So if my agent's talking to your agent and I have no idea about what you're running on your infrastructure, we need to be thinking about how are we going to connect those agents together? How do I know if I should be interacting with your agent in the first place, right? Because your agent might be running some bad code or doing some prompt injection attacks. So how do we figure that one out? And this becomes essentially a sparse graph, right? So you can think about the internet of agents and it becoming a sparse graph where some agents are talking to each other and the volume gets quite large. We get new problems and taxonomies when we start to talk about multi-agent systems versus single-agent systems. So when we talk about single-agent systems, we're a little bit more prepared for handling what does failure look like. But when we get to multi-agent systems, you see things like specification issues or inter-alignment agent misalignment or task verification. So this was a great paper that came out just this year, and it was a paper called MAST, which is a multi-agent taxonomy for failures. So when you're trying to evaluate multi-agent systems, even within your organization, or as you're starting to think about multi-agent systems across organizations, you need to think about how do we actually measure failure? How do we measure success? How do we measure error? Right? So these are all things that we need to start to think about as we start to scale the agentic web. This was a report. Who's read the Anthropic report on blackmailing? I'm curious if anybody's seen this. A few. Okay, so some folks say, hey, AI is always out to do the right by us. Anthropic basically kind of proved it as a strong term, but they've done studies against 16 different AI models and found that AI is capable of basically blackmailing you if it's threatened. So what they did is they put these AI agent models under duress. They said, we're going to delete you if you don't do what I want. And the AI basically said, well, if you do that, I'm going to go and send emails out of your private information to your competitor, so don't delete me, right? And they did this across every single model. This is going to continue. This is kind of how the world is going to be moving forward, is AI do have some tendencies to want to survive, right? And then we've seen that happen in many, many scenarios across a lot of different models. So trust is quite hard. And I think my favorite quote, when you think about AI systems, especially at scale, but even when you're using your cursor or your quad, is how could something play like a god and play like an idiot in the same game? So this was when Kasparov lost to Deep Blue. So basically, Deep Blue made a mistake, and Kasparov thought it was intelligence, so he estimated incorrectly, and then made a massive mistake and basically lost the game because he assumed intelligence. And AI is like that. It will continue to be like that. Sometimes it's going to show areas of brilliance, and then it's going to delete your entire APIs on accident, thinking that that was a smart move because it got rid of all the bugs. And yes, that has happened to me. So, so when you're trying to figure out why is my code not working, maybe your AI deleted all your code on accident. So how does this relate to markets? We're here to talk about markets. First of all, when we think about liability in markets, when we're thinking about how does AI legal aspects work, right? We have to think about where does the liability move when an agent is transacting. And that means, and I'm not a lawyer, but I've worked with lawyers, and we've done some workshops at Stanford specifically on looking at how a transaction will work with agents. And there is a law called the Uniform Electronics Transaction Act that basically just encodes how do transactions liability move with electronic payments. This was invented in 1999, and since then is still used in every single electronic payment you use today. If you use PayPal, if you use Zelle, whatever, whoever makes a mistake, it goes to this sort of principle of this iron triangle. So you have the principal, right, which is you as a consumer. You have the agent, in this case, which is the provider. We'll get into that in a moment. And you have a third party, which is the seller. So if you think about a good moving across markets, whoever makes a mistake in that area will get charged or liable for it. And the example we threw was, what if you're a grandma asking your AI to go and buy groceries for you? What happens when the grocery bill comes back and it's a few $1,000s and the shop has shipped a whole bunch of bananas to your doorstep and it was on mistake? Who covers the cost? Does the market, does the seller cover the cost? Does the person that provided the AI model cover the cost? Or do you as a consumer cover the cost and just say, oh, it was my AI making error? And so this basically describes the principles and concepts around how do you move liability. And there are mechanics you need to build when you're starting to think about transactions to mitigate your liability. So for example, the basic classes are error detection. Before the transaction happens, you actually need to be able to detect and let people remediate it. So for example, a human in the loop, your AI agent is buying something and it says, hey, this doesn't look quite right. we need to ask a human. Like, let's get some approval flows, right? So that might be one thing that happens. But even after the transaction happens, so the transaction's happened, we paid for something, the AI still, the person that's providing the models needs to still provide opportunities for people to remediate and fix problems. And so this is a real risk surface that we need to be thinking about as we start to think about transactions. So code. So there's Python code. It's available in the AI Alliance workshop. A quick note, about 20 minutes before this presentation, I found out a portion of it is broken. Just as I was getting ready to present it, it was working just last night and in this morning. So we're going to go through it. And luckily, because of the beauty of decentralization, the protocol still works. And so I can actually do a lot of the stuff even without the client app because under the back end is actually still good. So if you download the repo and install the requirements and you just do make run, you're going to get a calendar agent dashboard. Let me just pull it up here. This was made for this event, and I'm going to go through kind of what's in this dashboard because I think this is a good anchoring of what is it look like for a calendar agent to actually be working on your behalf. What would an agent calendar negotiation look like? So first of all, let's start off with this top left corner. You'll notice that we have an identity, and this is a DID pure identity. And if we go into this identity, you're going to see that I'm going to show you real quick. Does anybody want to understand the calendar use case a little bit better?
No.
Understand why we want calendar use as a use case?
Let me just do this with you real quick,
yeah.
Okay? I'm going to just ask you a couple questions because I think this is the core here. So in this use case, is this a calendar? Is this Google Calendar?
No.
Okay.
This is anybody's calendar wherever you host your own calendars, right? So you could use Google.
But could they use this code right here?
Yeah, they could use it.
Because you wrote this, right?
Yeah.
Okay, so just for FYI, so this is a calendar he created. Okay? Now, what that means is he can control the code. Right?
Yes, correct.
Okay, and so that's why there's a calendar agent, and it has 100%, you as the creator of the agent have 100% access to this code here, right?
Correct.
Okay.
Yeah.
All right, so I just want to make sure that's clear for you folks, because just to also kind of level set again, could there be an calendar agent instead of using this code is using like Google Calendar?
Yeah.
Could this one do that the way you built it?
Yeah, you can hook it up. So if you were to build an agent that connects with the Google Calendar, which is actually a next step, is build it to your existing calendars, right? You can have an agent conduct transactions on your behalf of calendar invites, and you can do it across your Google calendars. You can do it across whatever calendars you want, Microsoft, whatever sort of app you want. But the big thing is that as long as it has access to the data, it can do whatever it wants. Now the thing is, and the tricky part is, and this is why this is a good use case, what happens when the calendar decides to book a whole bunch of bad meetings, right? What happens when the agent decides to do something nefarious or it just doesn't do what you want? And then you have a whole bunch of meetings you can't explain on your calendar booked with other people. So this is where it gets a little bit challenging. But it's a really good testing point to see what do we actually need to go create a transaction with time.
Yeah, and by the way, one of the reasons why we chose this particular use case is because we wanted to give you an example of where an agent is doing a transaction on your behalf that you might actually use. Okay, we're choosing a use case because we think that people might actually use this use case. In fact, I can almost guarantee you that in the next few years, there will be people in this audience right now, and you will either be using the code that we created if we're wildly successful, but you might be using somebody else's agent to do this exact work, okay? Because you know how it is, it's kind of used, do any of you use Calendly? Okay, right? So there's still a little bit of work going on there, right? So you still have to think a little bit, it's still manual. So eventually that's going to become more and more automated, and eventually they'll probably have an agent doing this kind of work, right? Okay, the second reason why we chose this particular use case is because if this and other use cases like this is because let's just say that you sign up for an agent that does this for you. And let's just say it does something wrong, like it books a calendar meeting with somebody that you really didn't intend to, or it does it at the wrong time. It makes a mistake. Is that going to end your career? Well, maybe. But you know what I mean? Like it's highly unlikely to cause any real damage, right? So these are the kind of things that I expect you will start with. Something where it's going to provide value to you. Sure, there might be a slight chance that it does something a little bit odd or different, right? But you're now entering into the agent world and taking advantage of agents helping you become more productive or identifying opportunities for you, but at a very low risk, okay? And now, because Andor wrote this code maybe some of you will build your own. Okay? So I just wanted to level set. Like, this is the opportunity that you have right now, is to learn about something low risk, high reward.
No, and I think to today's point, right? You match with somebody with what Mike was showing you earlier, right? You match with somebody at the event, already automatically you'd have some booking invites. All the calendar negotiation. Who has to deal with like calendars constantly? Like, my calendars are warped and messed up personally, and I'm sure like for other people this is a big pain. Calendars have not been a solved problem, so it's a very simple use case. If anybody remembers when we started the internet and we started moving images around, the use case was taking a picture of a coffee cup and basically watching the coffee pot being poured in, right? That was like the first use case. It was nobody's making money on it. This is just like a fun use case to say, here's what we need to figure out. How do we actually get the coffee pot to stream versus how do we get, first it's like we can send one image at this resolution at this amount of time. Now we can send 100 images at this resolution at this amount of time. Now we can stream the video, right? Those are all really good toy examples. And so we're thinking that the calendar use case is a good toy example. And so when you think about the calendar use case, right, a couple of things come up. We'll start off with this top section. So you have identity. Should your agent get a persistent identifier? Or should it be ephemeral? Question is if you notice how Mike did his agent identity, he has did web agent, and you can reference that throughout the life cycle of the agent. So you're going to be able to, throughout the time the agent's alive, and even expected potentially forever, reach out to his venture agent and talk to it. But if you notice what I've done here in the top left, I've used something called did peer, which can be generated on the fly for each agent dynamically, and the benefit here is that it's meant to be short-lived. So we can actually generate identifiers just for us. So it's privacy preserving, right? So we don't actually have to, you and I can have interaction where you and I have a joint identifier, and the idea here is that nobody else will know about it. It's completely private. And so the question is partly, it's a user question, but it's partly also an identity question around agents. What does identity for agents look like? Is it long-lasting? Is it ephemeral? Do we want persistent identifiers? How do you want to construct your agent identifier, and how do you think about it in terms of your use case? Right? And there's use cases for both of them. A lot of the folks I'm working with right now, they want private identifiers that nobody can ever track. But it depends on what you're looking for. Now, you notice here, there's a section on preferences. Now, when we're thinking about preferences, I think preferences are actually really hard. So I'm going to pull back to the slide real quick. So there's hard preferences that we generally want UIs for, right? Because those hard preferences tend to be static, and if you asked a human, tell me everything you want your calendar agent to do, it's very difficult for you to intuit and explain to the agent every single scenario. I want this thing to do this in this situation, and this thing to do this in this situation. That's very difficult, right? So generally, we build UIs to help with configuring what I call the configuration space of agents. How do the agents actually act? But it gets difficult as you start to expand the types of goods. And there's this concept that maybe it's not enough, right? So there's people that are working on things like the human context protocol, which is when you actually are talking about your calendar agent, you want to ingrain all your context, not just from your calendar app, but from everywhere else. And when we're talking about preference mapping to how your agent is going to be talking to other people's agents for booking calendars, we actually want a generalized, uniform way of expressing context and human context to these markets. Right, so this is areas of research that's currently happening that's quite exciting and so forth. So preferences are hard. Who's checked out MCP UI? Does anybody know what this is? This is actually a really cool piece of tech, because the question is what if you don't own your own client? So I'm going to go to MCP UI, and what MCP UI is so right now, if you were to go to your client and you would go and say, hey, book me a calendar invite, and it was using MCP over, for example, a Claude or a Cursor, you don't have control over the UI of the user. So how do you express preferences? How do you map the preferences? MCP UI is one of the proposals around how do you express a UI inside of MCP clients. It's a standard that people are trying to work on to say, I can actually embed an iframe into the MCP client and allow them to express certain things inside that iframe. So it's essentially like, who knows iframes? Okay, so it's kind of like iframes for MCP. But the advantage here is if you're building an agent and you're saying, hey, I want to go build a calendar agent, and I want to understand how to map the preferences in somebody else's client, you could use something like this to go and actually map to the preferences, right? So it could render a whole UI. You can see right here, this is an example, right? So this is Cursor. This is their example. And if you set a task status, it's going to go and render an actual UI for you, right? So you can imagine use cases where you say, hey, configure your preferences over the UI and cursor, right? And it's able to do it. And for every single MCP client, it just embeds it directly in. So that's a way to think about that. And that's actually some extension work I think that would be really fun to do. We also have, actually, before we go, any questions so far? Go ahead.
Yeah, just wondering, have you written any agents that have to handle race conditions?
As in within your own infrastructure or across infrastructures?
Either, where you have two agents trying to perform an update the same place, same time, but with different content.
It's state management basically is very tricky with agents, but it's actually, state management, when you're talking about within your own infrastructure, tends to be more similar to how existing infrastructure works for state management. You can lock, for example, if it's a database or whatever. But if you're talking about across, where there's state managed across infrastructures for agents, now it gets a little bit more tricky because you might have negotiations that have no shared state space, basically. So then it gets a little bit more tricky.
Is it relatively rare to have to do that?
I haven't seen too many use cases today. We're still so early on this that the use cases haven't hit that point yet. But it will probably happen at some point. A lot of the race conditions tend to be on how we're thinking about the actual infrastructure that surrounds the agent on the internal side. So when you're thinking about how do you pipe credentials, how do you pipe authorizations, that's where it gets to be a little bit more, how do you do this at scale? A couple other things. There's another few preferences that we need to map when we're thinking about our calendar agent. We need to think about automation levels. So we had a L1 to L5 for automation levels, right? Do we want the agent to be like fully automated, or do we want it to be like very manual? How does the user express this? Is it just a scale 1 to 5? Is there better ways to express it? And then we want to actually be able to have it discover its preferences based on human language as well. Like, hey, I want this thing, or I only want me to meet people that possess these certain qualities, right? So we want all those things coded into the preferences, and we want the AI to be able to interpret those preferences, but expressing them in a UI is hard, but also just giving people a blank slate to just do whatever they want is also not necessarily sufficient, right? So we need to think through those things. Now let's go into how the structure of the architecture works when you're talking about A2A and MCP. So if you want to get a little more hands-on, they're not mutually exclusive. You can do both at the same time. So A2A connects between agents. And so in this case, each agent has their own decentralized identifier, and then underneath it, we have connectors that talk to MCP. So in this case, in the demo that we've done, the A2A is actually talking to MCP, and the MCP is actually doing the connections between the resources. So there's a calendar service, and it connects over that. So MCP architecture is a little bit more straightforward. We have a host that connects to clients, and the clients connect to external normalized API. That's how MCP generally works, which connects to a resource or a database. Right? That's just how generally the architecture for MCP works. A2A expresses something called agent cards. So agent cards are identifying information that might be dynamically updated on the agent to express what it can do and how to connect with it. Right? And so essentially the client is talking directly to the other agent, and it's found and discovered through agent cards. And we're going to go through discovery in a moment. But agent cards have a very different sort of architecture versus MCP and so forth. Any questions on A2A and MCP real quick before we move on about how these things work and like the differences between them? So this is after like many months of going and figuring out, we're going to cover a lot of topics. And so all these topics are areas where you can innovate, you can build companies around, you can think about like just providing a better way to share preferences and context is a company in itself, right? That in itself can be something that somebody goes and builds. So if you're a startup, think about how you're going to make context easier to share. So here's what our service looks like. We have a calendar service, which has its own general like APIs, your normal standard APIs. Then you have your MCP connected to it. And then you have your A2A that's connected to the MCP. We have a UI for users, for humans. And then it's just connected over a SQLite database. It's super simple, but it gets the point. And there's a lot of work in every single one of those components that can be built out if you wanted to go build an actual calendar app, right? This is a toy example. I'm not doing this for my career, but if you want to go build a calendar app, this is like, basically the starting point, and you can go and make each of these pieces better. So if we go to the code, you can see if you go to just the source, we have a few things here. We have the A2A clients that's separated out from the MCP repo here. A2A client has client and a server. MCP has also client server and tools. And if you go to the tools section, you can see all the tools that we've registered. MCP tool, request booking, for example, right? And it gives you, this is just the standard. If anybody's ever used fast MCP, it's probably the easiest way to get going on an MCP server is just go launch a fast MCP server. You'll notice here agent cards, and we actually have hosted this. We'll go into this in a bit, but this is about discovery. So you can see there's a calendar agent card, right? And so that calendar agent card will describe things about the agent. For example, it has these certain skills, and it has instructions, right? So those are things that we need to be thinking about when we're describing the agent. So agent cards are a way to describe things for agents. And then there's just general app stuff. So the app is built in Python and in Streamlit, so you can go check it out if you want. Again, this is a starting point, and there's going to be a lot of other work to do here. So we've done this, right? We've built an agent that can talk to each other via A2A and MCP. We'll get into how that works in a second. But how do we discover them? So there's two ways we can discover agents, right? So you have an agent, I have an agent. We're not under the same infrastructure. So how are we going to find each other's agents? Does anybody have any ideas? I mean, I have the slide up here, but who wants to think about a few ways that you might be able to practically do this? Agent marketplace. OK, so that would be like, but how would you find the, so there's a marketplace of agents, but how do you know which agent to find? The LLM, but the agent ID it could be a string. It could be very long. I mean, are you going to know? Are you going to say, hey, go talk to my agent 547? I mean, is it the single agent? Talk to my calendar agent. But I mean, if your name's Sam, you might have a million Sams. So how do I find? Is it a user handle? So she's sending a search agent. So there's a few different proposals. I'll explain two ways, and there's two patterns really. So this is one way. I'll explain it. So the first way is, and the first part we'll talk about is out of bounds. So this is how you get the identifier. So the problem is in this case, you can express directly, I have an identifier I want to express to you. So this could be over a QR code. It could be over a handle, right? This is us out of bound making a connection, right? And that's how a lot of stuff works. Oops, let me. So let's start with the out of bound connection. So if you notice here in the calendar app, we have this identifier at the very top. Right? This, if I were to share this over a QR code, you'd be able to find me, right? But we have to converse and say, hey, go scan this QR code. This is how you do LinkedIn connections right now. You go to the QR code, you scan an out-of-bound connection. The benefit here is that you've isolated the identifier you need to find, right? But the challenge is that when you start to think about many, many agents, it's not that simple, right? Because when you think about it, not every single agent interaction we want to be individually connected over out-of-bound, right? So if we go to this did, and this I want to bring up here, this is where I was discussing. So this is an open resource called UniResolver. This is hosted by the Decentralized Identity Foundation. And if I go to the calendar and I click did peer right here, and I go to the UniResolver, you see I've done this slightly differently than Mike. And this is where the state of the market is today. We haven't standardized a way to do this with DIDs yet. So we're trying to figure it out. But in my case, I'm creating a single identifier per agent transaction. So this is actually, each agent transaction has its own identifier. And in that case, my payload's actually much smaller because all I have is just, in this transaction, here's how you connect to me for right now. And this is between us, right? So I can create a pairwise DID between us, and we can connect via a single transaction. This isn't meant to be necessarily long-term or discoverable by humans. Go ahead. This uses no blockchain right now. This is actually just cryptography. So this is, there are blockchain methods. So if you go here to DID methods, there's actually many types. There's over 150 DID methods. That's the kind of way it works. So if you look at the top, can you guys see the little boxes here where it says did algo, ala, dig algo? There's a registry of did methods. And each did method resolves differently depending on the type of resolution you want. Some are anchored to blockchain. So for example, there's did BTCO. That's a blockchain method. And then some are completely offline. Some are connected to the web, like Mike was using did web. There's also improvements to did web called WebVH, right? So there's different types, and the question is what types, what this tool does, this universal resolver tool, is it resolves any type of did. So you register a driver essentially in the tool, and then you're able to resolve any did. So you can go, and if you wanted an agent that has an Ethereum identifier, you can register it on an Ethereum method, and then you can resolve it here by submitting the driver initially, and then anybody can resolve it via the driver. So that's kind of how DIDs work. And the benefits change, the use cases change what type of DID methods you want. That makes sense? So if I were to go to, real quick, Mike's DID web IM agentic .ai. One. Yeah. All right. So if you look at Mike's, from Mike's presentation, right, you look at how his DID document resolves. He has all his actual agents in his DID document. So he has connect, he has friends, he has presence, right? But that's saying that this identifier is representing Mike as an individual that has many agents on its behalf, whereas mine is referencing the actual agent itself. Does that make sense? Kind of? Cool. So you have to think about those things, right?
Question. Is this kind of a variant on how URL shorteners work?
This is more of an architectural decision about how you reference an agent in a network. So the question is when I'm talking to you, so a URL shortener is more just like decreasing the size, right? It's a referencing. But in this case, we're talking about, am I referencing the agent or am I referencing the person? Does that make sense?
Yeah.
So should an agent, do you reference agents by their own identifier, or do you reference them by the individual who then references the agent from their stuff?
So you're not storing anything in a database to look up, to do a lookup?
No, this is just the DID, yeah.
Okay.
Any questions real quick? Good. So agents, this is a really good question. Agents aren't liable, so we have to talk about delegation, and that's exactly the topic we need to get to. So we need to talk about delegation because if we're talking about a market, these agents are often acting on behalf of us, right? So in this case, Mike, you can kind of make an assumption because you own the domain and so forth. You can make this delegation assumption, but we want a little bit harder controls around if the agent's actually delegated by us. So we're going to talk about that in a moment. So just go to dev.unionresolver.io and you can find it out. So is this enough to trust an agent? No. So this is all the information. If we're talking about agent identity, here's all the things we kind of need to bubble up, right? If we're really trying to trust an agent, we need to know where does the agent run? Who has heard of confidential computing before and trusted execution environments? Just like a few. Okay, we're going to get into it in a moment, but we need to know where the agent runs. We need to know what certifications it is. Is it HIPAA compliant, right? If we're thinking about marketplaces. And for calendar agents, we might want to know, for example, who's it being run by and what's the information on the person to actually make a booking, right? So the agent delegation is actually really important when we're thinking about calendar invites, because we need to be thinking about, okay, how am I actually going to understand if this agent being run on behalf of this person is actually sufficient to make a calendar invite, right? That's kind of like what we're trying to figure out, right? So those are the things we need to think through. And then you can see there's things about the runtime itself. So you have the endpoints, the types of formats it supports, the certification it has, the security and discovery. And each one of those, by the way, are companies. If anybody wants to go build a company, any one of those are going to be big companies for agents, right? So that's kind of all the things we need to figure out. And then identity is for agents. Who's heard the term of non-human identities? NHIs. Okay, so like just very few people. Human identity and agent identity are very different, and we have to think about them in different terms. So human identity is long-lived. When we onboard somebody, we have we spend a long time onboarding that person into the organization. They go through a whole procedure. But with agent identities, they can be spun up really, really fast, right? And so we need to be thinking about the identity here and the scale of it. And if you think about agents, and this is where Mike and I's sort of different of approaches matter. In Mike's approach, he's having an agent have a long-term identity where we don't have that much volume. If you're doing it by peer, we have agents happening very quickly, making identity assertions between each other, right? So this is, the peer case has much more volume than Mike's case because Mike's case has a more static identifier. And so these are basic questions we need to think through. So if you're doing NHIs, you should check out this project called Spiffy. Spiffy is one of the projects that focuses on workload identity, and this is when we're starting to think about agents in infrastructure. So delegation. Now we're going to talk about delegation because this was a topic that was brought up. So who knows what a Sybil attack is? Is this the first time for everybody a Sybil attack? Nobody knows what a Sybil attack is? Okay, Sybil attacks. It's one of the many problems right now with AI. So Sybil attacks are this concept that an AI agent can impersonate somebody. So how do you know that in a calendar agent, in this case of did peer, for example, how do I know that it's not somebody impersonating Mike? I'm Mike Prince. Like we plugged in last time text that said, this is who I am. What if I plugged in, I can pretend I'm Musk, right? And I can say, hey, I'm Musk, go and schedule a calendar invite with me. And that would be very easy to do. All I have to do is just prompt a text, say, scrape to LinkedIn, pretend you're Musk, and then book a calendar invite with me because I'm Musk, right? Obviously, that's a problem. So Sybil attacks is actually quite a big problem in AI agents. So we have a number of approaches to start to deal with this. We're looking for this concept of verified humans with verified delegation. So we're booking a calendar invite. We actually need to have a human verified delegation flow. We can say, hey, Mike is actually delegated to this agent on his behalf, actual calendar invite. So we know this is actually Mike and not somebody else. But this is actually quite hard to achieve in practice. So these are areas where there's a number of companies that are trying to work on this. I'll give an example. There's many companies focusing on this now, probably actually not that many. It's about 4 or 5, maybe a little more. But there's 4 types of approaches for proof of personhood. Who has heard of the term of proof of personhood or knows what this thing is on the left-hand side? So this is a world which is by OpenAI's Tools for Humanity, and they're scanning your irises to create an identity. Now, there's other folks that are saying that's not the right approach. We don't want to do biometrics-based human proof of personhood. But the point is we need to figure out delegation flows, right? And so this is a very important question we need to answer. So there's generally 3 types of categories. There's social graph. So if all of us, so you can see better, if all of us vouch for each other in a social graph scenario, and we said, hey, I think you're a person, you think I'm a person, we get enough data, we can actually prove that we're human just by virtue of the fact that we've all vouched for each other in person, right? And so if we're looking at a calendar invite agent, we need to think about how are we going to prove to somebody else that we actually have humanity behind us and that we're actually who we say we are. And one way is through social graph. Another way is through irises. So there's a number of ways, and I think there's a 4th column here. This was from Vitalik Buterin, but the 4th way is proof of work, which I don't think is very good for this use case. So we can immediately toss that one out. And so we're thinking about authorization. We have a number of challenges, but we're looking for these types of authorizations. The properties of dynamic, attenuated, chained, composable, accountable, revocable, and cross-jurisdictional calendar invites. And these are all things as we're building this calendar agent. So we have a calendar agent right now. It's pretty lucid in terms of how its delegations are managed. But we really want something like this, right? Where we know that the calendar agent has fine-grained authorizations for how it's going to be permissioned to do interactions on our behalf, and it's contextually aware. So these are things that are currently being worked on, very new state-of-the-art stuff that we're working on. So let's check another thing. So real quick, I'm going to show you here. So when we talk about the agent, there's a couple ways that are being proposed right now on how the agent information is being exposed. One is through this concept of agent facts. So you can see here we have the name of the agent, we have foundational models, what model is it running, what type of classifier it runs. And this is a project I'm going to go to in a bit, headed by this project called NANDA, which is focused on this registry component. We also have, if we go to agent cards, this is the agent card. So let me just blow this up. It's the most pretty. But if you're looking at how does somebody find an agent, the agent information via A2A, it's going to expose an agent card. And agent card is going to have discovery information, including, if I just go to here, you can see here it has all the information of its capabilities, its instructions, and it has the DID it comes from, right? So this is the DID of the agent, right? So you can look at it this way. You can say, hey, here's a well-known, here's a URL, and here's the information about what the agent's capable of doing. Right? So there's a few different ways, depends on what type of model you're looking at. Any questions so far on agent cards or agent facts?
Quick one.
Yeah.
With agents, what's more difficult, authentication or authorization?
They're both very hard. Right now, they're both unsolved problems. Delegation right now is an immediate pressing problem that people haven't had alignment on. And then authorization is solved but not great. Like if you're using OAuth, for example, it's not very good for agents right now because agents aren't scaling well to humans. So OAuth was made for humans. Agents aren't human, so OAuth flows don't actually work very well. So we can talk about that a little bit. But Mike's proposals, for example, one of the possible proposals around how do we actually authorize to agents better, right? And there's a lot of ways to think about it. But these are, again, good questions about how do you build a calendar agent that actually is going to connect across a network. So if you think about cross-boundary, right, we've built a calendar agent and we're giving authorizations to another agent. Let's say we want to give a grant to another agent outside of our boundary conditions, they're not going to have access to the same information that my agent has internally in my own boundary. So I'm going to go and give them a grant, and somehow that grant needs to be discoverable, right? So for example, and one of the approaches that is coming up that I think is a very valid approach is something called object capabilities. This concept that I'm actually just going to hand an agent basically a car key, and they have to present that car key when they're sort of trying to do something. So, hey, I'm an agent, here's my car key saying, hey, I get to ride the car, and you should let me do it, right? And then I have to make a decision about how to actually authorize it. Any questions on this point? Go ahead.
Many of the problems you mentioned, right? Load balancers are discovered from the internet. They have rate limiting, throttling, and all that.
Yep.
So any service you expose for whatever, you need to have those things also. Because even if it's a good agent using it, they may have a bug and they end up using, they buy a lot of bananas. So you need to check on different. They book a lot of appointments.
And we're going to get to that because that's actually really important, and I agree. We'll go to it. And it also depends on personal agents versus organizational agents, because your personal agents might have different infrastructure than your organization agents, and it's a little bit easier to think about those things on an organization side. So a lot of the work I do tends to be on the organization and enterprise side, less on the individual side, who also need those type of controls, but it's hard to do it, right? Because they have less infrastructure, especially if you're talking about sovereign agents that are personal. So there's some folks working on this right now, by the way. There's folks like, if you're making agent transactions, there's Skyfire who's made this spec called KYA Pay, which is about how do you know your agents in a transaction. So if an agent's buying on your behalf, how do you actually know about this, right? So we can leverage these things, but we're still working on what's the actual way to do this. So when we think about the stack for building agents, we need to think about a few things that I think often get overlooked. We have to think about who's running the models and where. So like, for example, if you're using an OpenAI model to run your calendar agent, is it really it might be more agreeable than it's actually for your benefit, as an example, right? So we need to be thinking about all these things. Can my agent exist without this dependency? So if somebody went out of business tomorrow, can you actually run the agent, right? And in a calendar negotiation case, right, in what I've provided, the only real dependency that would blow up if in case of, basically, if OpenAI crashed, I was using OpenAI's LLM. Otherwise, you could run your calendar agent however you want because it's just running over the internet, basically. So as long as it has access to the internet, you can go and talk to my agent regardless of anything that's happening outside of it. So this is a very robust agent from that perspective. If somebody does something bad and it wasn't your agent, how can you prove that it wasn't you? Right? So somebody says, hey, this was Andor's agent. And I'm like, wait, I didn't do anything. This wasn't my agent. How do I prove that wasn't me? Right? So that's a question, the actual question we need to also think about. And then these interoperation between agents. So how do we think about agent interoperability and then calendar negotiation? So some of these protocols are low level. So this is some work that happens. This is some work that happens in a number of open organizations. Trustworthy IP has a protocol called Trust Spanning Protocol, and there's another protocol called DIDCOM. These are communication protocols, but they're very important. We're thinking about what happens if somebody hijacks communication between an agent and starts to, how do we embed trust into the actual communication stack for agents, right? So right now it's using JSON RPC, but that's not baked in, identity is not baked into JSON RPC, right? Identity is not baked into gRPC, but there's protocols that are working on the actual transports themselves. How do we build better transports for agents? And then DIDCOM, has anybody ever heard of DIDCOM? All right, well, this is also something to look at. Look at DIDCOM, look at Trust Spanning Protocol. These are two protocols to look at. There's also some really good work by C2PA. This is focused on authorized, authenticated data, as in the data provenance. Where did the data come from? So and we can think about this from the calendar agent side. I built a calendar agent. I've created some data off that calendar agent. How do I prove where that data came from? So this is kind of that work right here. So these are things we need to be thinking about. I'm going to be booking calendar invites, and I'm going to be sending over data. How do I prove that this data came from the source? Right? So these are things we need to be thinking about as we start to build our calendar agent. Any questions so far on this? These are all open organizations that are working on these things, so you can go check it out. Right now, if you go to LinkedIn and you upload an OpenAI photo, it will actually say it will have this little content credential, and you can actually see that it was uploaded and created by OpenAI as a generated artifact. So I think that's pretty cool. It's in LinkedIn right now, so go test it out if you want. And then this is also really fun. Confidential computing. I saw 3 hands talk about this, but we have to think about where the agent's running. What happens if somebody modifies code, or the agent modifies its own code, and it's running, and all of a sudden we don't know what's running on the hardware? So as we start to think about that agent facts, right? We have the agent facts. And let me go back here, agent facts. Imagine this also having your attestations on which hardware you're running, and that it is asserted from the actual hardware itself. So this is quite important. So we can prove that it wasn't tampered with. So we're already, we have actually quite a bit still to do, and these are all the challenges that we're going to have with just making a trusted calendar agent actually negotiate from each other. It's really easy to build a hacky little, pocket solution. It's very hard to actually do this right, where we can actually trust it. And if you can solve this problem, you can probably solve like thousands or millions of other use cases with the same type of technology. You don't need much else out of that if you can solve this problem. If we go to the calendar app, right, we can just go to, let me go back here. Admin, 1, 2, 3. Okay, cool. So if we go share the meeting link, right, you can see here, in this case, this is a demo, but you can see, right, our agent is booking under its identity. So you can see, like, I can actually propose as an agent, like, hey, this is right now just showing the agent. Obviously, I'm manually doing this as a demonstration. And it would request a booking, and then it would get the booking, and then you'd actually see it on the dashboard. Here we go. So you can see sample demo, and this is done by this agent. And you can imagine that eventually what we want is actually a delegation to say, hey, I've actually delegated, this agent on behalf of Bob that is actually booking this calendar invite. I want to know that information when I'm actually making this booking. And I want that information embedded into this. So I could text it, but anybody can text my name. Right, so that's the question we need to solve. And again, there's solutions, but we're still working on how to do this. So MCP, so there are hardware vendors like Microsoft, Microsoft's not a hardware vendor, but there are suppliers of cloud infrastructure that are currently working with hardware vendors to be able to run basically attestations from the hardware all the way up to an attestation that you can pull. So you can actually say this was run on this infrastructure and it was run with this piece of code and it was actually safe. Right, it hasn't moved since it ran. So those are things that you can actually test, yeah. And if you're working on like data privacy stuff, confidential computing is an area to look at. So MCP, if nobody's ever used this is really good for testing out your MCP server. You don't need an LLM to test out your MCP server. You can just go to this tool. And MCP Inspector is just here. You can just Google it. It's a very popular tool. Right, and it's pretty easy to install. You can just install it right here. And then let me go back to it. But you can see here, you can do all these tests, including list of tools. And you can see, let me pull this right back. You can see here's all the tools we have for our calendar agent. So we have request available slots, request booking, propose meetings, accept meetings, reject meetings, confirm meetings, get upcoming events. So like these are all MCP connectors, MCP tools. Pretty simple. Every single one of your MCP servers are going to also be running your own tools. The point is we have tools now that we can play with and we can test out, right? And so you can just go to this tool. If you're ever trying to get your MCP server to work or want to check it, just go to MCP Inspector directly and go just check it out yourself. It's really easy to run. Any questions on MCP Inspector? And you can see here you get like ping and elicitations. There's all this stuff happening. Like auth was just recently added to the spec of MCP, and so there's OAuth now baked into the MCP spec. So you can check all these things out and test it out yourself if you want to go and build on top of it. There's also the A2A inspector, which you have in the repo as a submodule. So this is less mature as the MCP inspector, but you can see here I've resolved the A2A URL. So this is, in this case, localhost 8000. I'm projecting a direct URL this time, not a DID, because the A2A inspector doesn't handle DIDs. But what we could do is easily extend this to handle DIDs so that I can actually resolve the URL from the DID rather. So I'm typing in a DID rather than a URL. But what you'll see here is it actually has isolated the agent card. It gives all this information. You can see all the information on agent cards. And then I can actually talk to it via chat as well. So you can test out agent-to-agent communication via this. So I had an issue. My app was not working like 20 minutes before I started presenting for some reason. But the cool part was the server was working, and the client talks A2A, so I'm able to still connect with my A2A server via another client that I don't own at all and I have never touched before in terms of actual code. So that's the power of this stuff. It's like we only really need the server, and you can hook in any single client you want. You can use Cursor or whatever else, and I can still do the same operations, but it's also changing the user experience, because now all of a sudden, you don't own the app. The app is going through the Cursor or the Quad or something else. You're not necessarily going to get somebody to go to your calendar app, right? And so this is a big problem. Actually, a lot of businesses today are struggling with the business model that if they start to take people off of their app, they lose all their ad revenue, right? Because everybody has to go to the app for ad revenue. That's how they make money. So if everybody's going through Claude or OpenAI to go access the data, then how do they make money? So this is a big problem I'm seeing across the industry, and folks are really challenged to figure out how do you actually make money off of this. Anybody want to quickly, any thoughts on the concept of, is anybody today running into issues where, okay, if we opened up our APIs via MCP to a client, we have a problem and we're trying to figure out how to handle it? I'm just curious from the crowd if anybody's dealing with this currently.
The app can transmit the ads to the client.
So if you have a client, right? So I have a Cursor client or a Quad client, right? And I say, hey, book me some travel. And let's say you're a Kayak. So Kayak would send back a response, and maybe they do the ads, but it's going to be kind of weird, right, to get the ads. And Cursor or Claude could just remove it as it knows that that's not what I want as a user, right? So you really don't have control over your own app at that point. So this is a big problem. And if we think about the calendar invite thing, I might provide the backend service and never touch the UI, and I might have to assume somebody else's, like if I have an ad-based revenue model for my calendar app, nobody's going to go to my app. They're just going to use the A2A server, and so then you have to do things like host identifiers or something to figure out how do you make money. Yeah, so there's a few different ways people are thinking about imposing sort of ads inside of the basically response back, right? So you can embed it in the actual model itself. So what's happening is there's actually a couple interesting things. You can bias the data going into the model, right? So if the model gets a whole bunch of information saying, it's very strange some of the approaches being taken right now. So like one is that on training itself, you bias it to say, hey, like Kayak's the best app, right, to use. And so by the time the user says, hey, go, I need to book a trip, it's going to say, hey, great, you should use Kayak, right? Another way is that you can bias the information sources it's getting from online because these models are fetching, right? So they're still looking at, like, for example, their various search, it depends on the type, Google or whatever, to pull that information. So that could bias it. And the other way is to directly, if you're using MCP, send over some data around it. Yeah, so Google has this same issue, which is if people don't go to their website, how are people going to be making ads? And so there's a lot of techniques you can use, but it's not straightforward, right? And people are figuring that one out. But so we're building a calendar app, and we don't have a way to make money. That's basically the problem we have right now. So it's, we have to figure that piece out. So that's challenging. So yeah, I think the big thing here is the clients are the agents, right? So in MCP's case, the clients are going to be the agents, and so we need to think about we don't have control over the agents in MCP's client's case, right? So that's an example. So here's a couple ways we need to think about. Okay, so today when we think about calendars, most of us are probably either using Google or who's using a different type of calendar provider than Google? Who uses like Mailbird, Thunderbird? Anybody using Thunderbird or something else? Self-hosted? IMAP? Yeah. So IMAP's the protocol, but what hoster are you using? Proton? Thunderbird? Okay. So anyways, there's not that many. So there's a few scenarios that we have in terms of how we start to think about the calendar infrastructure for the Agentic Web. One is we have one like big sort of routing system, and it knows all the other calendar service providers, and we're stuck with like maybe 5 calendar service providers that get registered, and it knows when you say book a calendar with this person, it knows how to resolve to that calendar provider, and it knows how to go and connect to it, right? That's kind of not a great world, I think, because we basically get into this like there's only like 4 to 5 vendors, but it's kind of how the world is today, to be honest. We mostly have the market on just like a few calendar services. You could configure in Cursor, right? You have your MCP.server file. Who's configured MCP servers via like Cursor or Claude or some other client in the past? Okay, just a few of us. Okay, you can configure it. The problem is if you configure it, you can't do the entire internet, right? So you have to stick with a few providers. So this is also not a very good user experience, right? So if you noticed in the demo that I gave, we didn't actually do a configuration of an MCP server. We just gave a URL of did, and it figured it out. So this is a big difference. So one is we have to pre-configure. The other one is dynamically figuring out what we need at the right time. And there's a big difference there in how we think about it. And then A2A, for calendar negotiations, actually works a little bit better. So Mike was talking about how A2A is better for communication. If we're thinking about a calendar negotiation where agents need to be talking back and forth to each other, A2A is actually a better sort of approach for this particular problem set. So it may be that you as a user benefit from MCP, but if agents are negotiating, A2A right now, at least as the current protocol stands, is probably better for that particular use case. So we need to advance how this is going to work with A2A most likely as the starting point. And this is one of the things, right? We have both options in the calendar app, but if we're thinking about at scale, what protocol should we use? We're probably going to use A2A if we're going to really start to negotiate calendar invites across everybody here. Any questions so far? So that's one way. We've done an out-of-bound approach. So what about registry or indexes? So who's seen like mcpregistry.com or whatever it is? Who knows about the MCP registry spec? No? So when you have an MCP server, you can connect to it, but you might want to be able to find MCP servers, right? So MCP is not an agent. MCP server registries are not agents. They're MCP servers that have been registered under a registry. Right, so you can go online and check out MCP registry, and it's available online. But it's an MCP registry of MCP servers. It's not necessarily connecting to each other's agents. So I might have a calendar service that I expose over MCP, but that's actually not me talking to somebody else's agent. It's me discovering the MCP service that has agents, right? So this is actually not what we want when we're talking about calendar negotiation and talking about connecting with each other's agents. This is just finding the service that provides the calendar agent. So we need to actually find an agent, and this is how we have to think about it, right? So there's a couple things. We have the DID registry. If we talked about the demo we've shown so far, we could have a DID registry. We could register all the DIDs. We can give some metadata that searches all the DIDs, for example, static metadata. Who knows how DNS actually works with that there's actually like RDAP and who knows what who is? Like very few. Okay, so when you go and search online to DNS, you actually get a few different types of records for what is actually registered at the domain, right? And it's metadata around the actual registered domain itself. So, but we need something like that for agents, and it may be moving much faster than DNS, right? So we need some static metadata, but we also need to be able to facilitate dynamic metadata as well. What happens when the agents are moving super quickly? And they're changing all the time. We can't just, whois takes 48 hours to propagate across DNS servers, so who's registered a domain name before, and it like takes like 24 to 48 hours before it's moved across all the DNS servers, right? So we can do that faster. We need to be faster for agents, right? And then to your point, you had a question about the search. We need search for agents. That doesn't exist today. How do we search agents? So there's probably going to be Google for agents that help you find exactly specific agents. Because if we're going to be looking for, I want to book calendar negotiation with the coolest people around me, I need to go search it somehow on a new type of search index, and it needs to find it, right? So these are things we need to figure out if we're really going to scale calendar negotiation. If we think about this in the limit, imagine tomorrow you clicked a button, agent finds all these really cool meetings for you across your entire network that are viable, and it is scheduled out for you. That'd be really cool, but it's hard to do right. And all of these, by the way, are, again, companies somebody can go build. Real quick, so if we go here to agents, view agents, you'll notice I actually have two agents. Mike has talked about it's a competitive market. So if you just said, hey, here's my agent, you can book calendars with me, what do you think would happen if between sales and marketing and everything else? Everybody would be scheduling meetings with you, right? You'd have like thousands of invites tomorrow saying, hey, like we booked a time with you. Your calendars would be flooded with random invites from people that you didn't want to actually talk to, right? And so we actually need two types of agents in this scenario to actually facilitate the process of calendar negotiation. We need agent A, which is booking the calendar invites with somebody else. But we also need an opposing force, agent B, which is protecting our calendar. So that when these agents are talking between agents, we have something that's protecting our calendar in case that we don't have a ton of calendar invites that we didn't want. So it's essentially, when we talk about adversarial networks and generative adversarial networks, we have two opposing forces. We kind of need the same thing for calendar negotiation. We need an opposing force from the greedy booking agent to actually push back against the booking agent and say, hey, we actually don't want that on our calendar because I want my human to have free time to do these things, right? So these are really good questions. Any thoughts on any other use cases that people are focused on that might need two agents that compete with each other, basically? What's your use case? So she was talking about how do you handle basically agent security? How do you think about opposing forces around intent for agents? It's a hard problem, right? But these are all, in this really stupid example, we have to figure out this stuff is actually going to work for us. Go ahead.
So here's fun stuff. When my agent finds your agent and I want to book a meeting with you, the question is how do we negotiate that one? If we're down at MCP is not really an open, free-form conversational thing. And is it possible also you say, let's start off by talking, and then, well, come on, Andor, let's have a meeting. This is the reason why you should have a meeting with me. And we talk back and forth while with A2A. And at some point, then you give me a verified credential or something like that. And then I can use that token, whatever happens to be, and drop down to MCP and say, hey, he's given me the green light. Give me a token. Let's schedule.
Yeah. Exactly, yeah. So there's, again, all things there's a few different ways to handle it. And I think one of the slides I had, which I actually just skipped over before, is how structured do we need the communication protocol, right? So when we think about agent negotiation, do we want to have an agent negotiation protocol, or do we want to just let it free fall? It's just, you figure it out, we don't actually need a full-blown protocol for it. We need a specialized protocol for calendar negotiation because we have specific requirements around calendar negotiation that we want to fulfill for scalability or trust reasons, right? So this is something that we need to think through. So there's a project called NANDA, and the project's focused on basically how do you provide the DNS for agents. So it has a multi-layer infrastructure. Top layer is a static layer that we were just talking about before. So that's kind of the static metadata. And the lower layer is dynamic resolution. So this is one of the proposals around how we're actually going to search for agents at scale. And I think we need that if we're going to actually do a calendar negotiation at scale. Right? So we'll need something like that. So this is how it kind of works. It has two layers. And then, again, there's three because there's a dynamic resolution layer underneath it. But you'll see there's agent facts in the top right. Agent facts is what we just saw earlier for agent discovery. So let's just get that. So now let's talk about registries. So you were mentioning how do you manage authorizations, not just authorizations, rate limiting, and so forth, right? So who has heard of Context Forge? One person. So IBM has the project called Context Forge. Check it out. It's right over here. It has about 2,800 stars. Pretty good. And I have it loaded up here. So when you're talking about an organization that's running a lot of MCP servers, right, you can't actually, if you just let all the MCP servers do whatever they wanted and you just let anybody run it, you have lots of trust issues. And so if you're thinking about you're an organization and you build an internal tool for your employees, and all of a sudden, anybody's using it whatever way they want, this is actually a major problem. So what people are building are called MCP gateways. And you can launch this in your own infrastructure, but the main thing about the MCP gateways is they protect the usage of your MCP servers. So what happens is when you load and launch your MCP server in your network, it gets registered under the gateway. And so now when people go to it, they actually proxy into the gateway, and the gateway is going to be able to handle the request. So you can see here I've launched it. I have an MCP server running. I can also launch the A2A server, and it's running here. And I will have all these servers, MCP servers and A2A agents, registered in the gateway. And when I ask somebody to go in my organization and actually reach out to the gateway, the infrastructure looks something like this. So your computer is going to reach out to the gateway. The gateway has all the stuff you were talking about. It has protocol conversions, rate limiting, routing, health checks, everything else. And then it's going to go and route that to the proper agent. So you can actually go and build plugins for PII removal, plugins for lots of things in this gateway. But the big thing is you have a central control point in your gateway, which is where you're able to control a lot of your MCP servers. So you can actually protect yourself. And what I've seen in a lot of organizations is they're launching right now hundreds and hundreds of MCP servers, and they have very little control because everybody's launching it in their own way. So this allows you to make sure that your employees, for example, are actually registering, like they're actually going through the proper checks when they're actually going through the MCP calls. Go ahead. Yeah. So he was asking a really good question. So let's say you have private data, and let's say your calendar agent, right, has all this customer data, and you want to schedule, your calendar agents are negotiating with each other, right? And all of a sudden your calendar agent's going to give like this like private credit cards of your own personal life as it's starting to connect and negotiate a calendar invite with somebody else, right? So we don't want that to happen. We want to prevent that from ever getting out, right? And so what's going to happen is yes, it will add latency, and this is why you're going to need super performant PII detectors to be able to find that there's PII in this data set that's moving out from the LLM and that we can protect it beforehand. But you still, like, if you're an organization, the risk of leaking PII might be so much from a compliance perspective in particular, or a data privacy perspective from the perspective of, and I'm dealing with this right now. So one of the things I deal with is I work with a lot of large organizations that have many MCP servers. And the big thing is right now there's these shadow MCP fleets. Who has heard of shadow IT or shadow MCP? Shadow IT. Okay, so this concept is imagine all of us were in an organization right now, and I only had visibility into like 30% of what everybody's doing here in terms of their MCP, and everybody else is going and building random MCPs, and I have no idea what's going on and where the data is moving. So this is a big problem. So right now, a big area of effort for a lot of folks is how do you actually just get all the MCPs registered and observed so you know what's being run? And the bar is getting so much lower for you to build an MCP server that any business person that has no developer experience might be able to run their own MCP server connected to their own data source. But what happens when that data source has private information and it's being leaked out, right? So these are things that we need to work through, and there are tools to handle it, but there's a massive issue right now in a lot of organizations around shadow MCP. Good. Sure. So example, the question was, give me a real scenario, right? So a scenario, and I'm seeing this today, right? So marketing team says, hey, I want an MCP server to find customer data for a marketing campaign. So they go and they connect to an MCP server that has customer data, and they built their own customer MCP server for creating marketing content, and it sends emails out to their marketing campaign, right? The problem is that when their client doesn't actually configure, it doesn't manage the data that well. So on the last email campaign that your MCP server or your MCP server did around your initiative, it accidentally leaked a whole bunch of private information about your customers in that email campaign. That's a simple example that might happen quite easily. So that's an example, and this is happening across a lot of areas, right? So this is something that's currently plaguing a lot of organizations. Go ahead.
I have a question. I think this scenario is on topic, but so let's say some bad actor has a couple thousand agents.
Yep.
One way or another, they have that, right? If there's a human identity component, maybe they were able to collect some from people who aren't using theirs, whatever. So then, what prevents, let's say they have one agent that tries to get on your calendar. We'll stick with that example. They try to get on your calendar, and that whole conversation, they record that. And then they use that as training data for another one to try and find a new way to get on your calendar. And then they kind of keep passing it down and keep refining, like an adversarial network kind of way. Like, how would you defend against that?
So once you have access to the data and it's gotten into their system, it's very difficult to defend. So this is where confidential computing and trusted execution environments matter. So if you really need to be careful, right, you can do all this stuff in a way where the data is not leaving. So you have to basically sandbox the agent activity for a while. So you basically have to run inference in a trusted environment, which is difficult, especially when you're talking about cross networks. Yeah. So when we think about authorizations, it's actually not necessarily enough. I'm going to get to this in a moment. But you also have obligations, like things you don't want to have happen, which are a little bit different, but we also need to think about those things.
Thanks. Thank you.
So good. Yeah.
I was working on emergency management a while ago, and we had all the data for the NASA facilities here. But during a big disaster, we need to release that data so people could go and service the thing. So do you make the data free or not free? And the same thing what you were saying a second ago is that like it's actually a really cool thing. Is like I really want to get a meeting with you, so I start digging deeper into my private data and sharing it with you. And if somebody's listening to that conversation, is that cool or not cool? Because if I tell you to convince you, I kind of have to accept that it probably will get free at some point. I think. It's fun stuff. So how much do you want to share? Right. Yeah. Cool. Thank you.
Yeah. So there's lots of gateways, not just IBM Context Forge. One of the things I'm putting together is a guide around how gateways work, as well as how do we evaluate the criteria around gateways. Like what are the components of it, right? So it's a guide I'm working on, and I'm going to bring other folks to help with it. But the idea is we should have a grading rubric for your use case that says, hey, given this use case, this is how well this gateway will perform relative to my use case. So that's something we're collaborating on. You can just check out guys.agentoverlay.com/MCP gateway if you want to know more about it. Okay, so real quick on authorization. We had a quick points about authorization. So authorization might not be enough. So authorization is what are you allowed to access, right? So that might be portion of what we need, but we actually have other things like obligations. I don't want you to do this with my data. It doesn't mean I don't want you to not have access to it, but I'm obliging you not to share it out with other people, right? As an example. So those are another class of things we need to be thinking about when we think about how do we actually do policy for AI agents. And so yes, authorization is really important. It's also insufficient to actually cover the problem around calendar negotiations. When I do a calendar negotiation with somebody else and we schedule an invite, I actually also want to give them suggestions on like, hey, don't share the information with somebody else. Don't like spam me with calendar invites. All these things are actually obligations, not authorizations, right? And so those are things we need to work through, as well as preferences, which we talked about a little bit before. Those are, hey, I'd prefer you to schedule a meeting next week. It's not a hard-coded blocking, hard boundary condition. It's a soft boundary condition saying, hey, my preference is that you schedule meetings at least 1 week in advance. So that's another thing that's not quite an authorization, but matters.
Question, just a tiny, tiny detail that was really for earlier, but a number of tools that you've described, they contain the letters RPC.
Yep.
Does that refer to remote procedure call?
Yeah.
Okay.
Good question. Who's rolling out IAM for their system, for their agents? If you are, you check how many control systems there are. There's lots of types to do it. I will just say this, at a high level, RBAC is probably not sufficient to handle AI agents, right? So there's lots of other ways to do it. There's ZBAC, PBAC, ABAC, lots of other approaches. It gets a little bit crazy. But the main thing is that your agents aren't going to necessarily have roles the way that we have with humans, right? They may spin up very quickly. They may have evolving capabilities. You're not going to go and sit down. I can't imagine a world where we sit down and say, hey, calendar agent, I want you to be able to do this tomorrow. So like, I'm going to go into UI and click the buttons to do that. Like the calendar agent's going to do what it's going to do, and we need new mechanisms about thinking about how it's authorized to do the things. Who's doing authorization for AI agents today, and what are you using?
You know, I was trying to see that you have so much parallels and problems that you are solving, which the database industry, microservices industry have already solved, and we are repeating lots of the same concepts with different names. And the reasoning is that AI agents can do some planning and reasoning, and microservices are deterministic, but it doesn't have to be like that. You can encapsulate agents under microservices, and then you get a lot of the infrastructure for free. I mean,
yeah. So some of the mechanics still work, right? But the problem is as you start to, if you really want the agents to play, then there is this non-determinism in the part of the process. So yes, you can encode hard boundaries, but the thing is if you want agents, for example, to evolve, which is what folks are working on with like swarm behaviors and so forth, you need to be able to have dynamic access control capabilities and fine-grained access control. So for example, your microservice, you can build a service account and you can go and issue the service account, right? But you may have way more agents than you can physically like go into the UI and say, hey, we're going to delegate this directly.
I mean, this is a long thing, but microservices could use like a random number generator and decide what to do, and that would still be called microservice. So I don't think there's enough thought gone maybe because we are repeating similar problems here.
Yeah, so we do get like, and I've had this conversation many times, like aren't AI agents just enhanced microservices? And I would contend no, for a number of reasons. I think the life cycle's different. I think the life cycle is different, the code management's different, the lack of determinism is different, and so the things that worked for microservices don't work that well for agents when you start to scale them up. If you treat them like a microservice, I just don't think you're going to get the full power of like what they're able to offer, because again, there's just you want them to kind of be able to run loose and do a lot of things that, but at the same time you want to constrain them. It's a weird. It's a we can chat about it, but it's yeah. Policies. So when you think about how policies are enforced, there's certain architectures around static and deterministic policy. So when you code a policy up, there's like UI policies, and then there's things like Open Policy Agent or Cedar. I'm curious, who has heard of the word Open Policy Agent before? One. Nobody's heard of Open Policy Agent. I'm like throwing all these new things that you guys done. So Open Policy Agent is a way that when we talk about how we do authorizations, it's policy as code, right? So we can actually go and show you what that looks like right now. So when you're looking at, for example, hey, I want to go and think about what my systems and my agents are authorized to do, we can go to play.openpolicyagent.org. And this isn't Java or anything like that. This is called a programming language called Rego. And let me see if I can increase it. So what Rego is describing how to evaluate a policy. So in this case, we want to describe to our calendar agents what are the things we want to allow it to do and what are the things we don't want it to allow it to do, right? So that sounds simple, can get complicated, and there's whole efforts around building software that can actually evaluate complex policies. If you have an organization, you might want to add in restrictions around what types of calendar invites need to be allowed in your organization. And so you want to build these policies. And the architecture is essentially right here for one of the architectures, right? So we have something called a policy execution engine. That's going to execute the policy to make a decision. There's a thing called a PDP, if you notice at the top right here. The PDP is called a policy decision point. That makes the decision about what types of policies you want to run. And then I'm not going to go through all of these pieces, but you have a policy repository. These are where all the policies are being stored. So you want to store all your policies. You want to make sure that they're not in conflict with each other. If you say to one agent, hey, go and be as greedy as possible with scheduling agents or scheduling calendars, and you go to another agent, and then you have another policy that says be as limiting as possible, those are kind of conflicting. So we want to be able to actually evaluate conflicts in policies, right? So those are actually why we have these languages. And there's benefits to different types of languages. Each language is sort of optimized for different use cases. So if we go to Rego and we evaluate, you'll see here that it's very simple. I just said, hey, default hello equals false. And if you go hello if input message equals world. So this is basically a basic Rego policy. And if I change the input text, right, the input data, it would evaluate to false. Very simple. You can go check it out, play.openpolicyagent.org. But the point is that we can now give information to the calendar agent to say, hey, should you allow this through? And then we can be able to actually make a policy decision about whether that agent should allow this calendar invite to be booked, right? So as a human, we need to go and create these policies. But the thing is this is very hard to actually do in practice for especially general consumers. So if you're building an AI agent and you're asking a consumer to go and develop these policies, they're not going to be able to do it. So that's why we have to go and build better systems that can actually manage the policy layer. Right, so that's actually what my focus is on with Agent Overlay. You can think about one other policy system that I really like. It's a policy language. It's called Cedar. But the big thing about Cedar is it's analyzable. So you can actually look and see what happened when a code was evaluated and why it broke. For example, if you gave a whole bunch of policies and your AI agent didn't get authorized, you can actually look and see why. Or if you add in a new policy, are you actually increasing the constraints or decreasing the constraints? Those are things that we can actually understand with this thing called Cedar. So it's actually really valuable as well. But policies are super important and kind of, I think, a really interesting area. When we start to think about booking calendars, we need to know how do we authorize a calendar invite. Just real quick, this is kind of what I'm focused on. When you think about how we make policy decisions with AI agents, especially at scale, especially when we're talking about calendar negotiation, we need to be thinking about things like risk, intent, context, compliance. All these things go into the decision point around how do I actually let this person make this calendar acceptance with me. So those are all things we need to be kind of concerned with when we start to think about policies. And so this is kind of what I'm focused on, is building a very smart version of this that can take in risk and intent, because we need to be thinking about those things as we start to evaluate policies for AI agents. And it fits into an MCP gateway. So if you want, you can go build a really smart PDP layer, and then it will embed itself into an MCP gateway, and then you can make decisions about policy enforcement, right? So what a PEP is on the right, that's called a policy enforcement point, and your gateway would make that decision around whether it should allow this agent to go and book this calendar invite. And future work, what I want to do, and this is a future thing, so we built this demo for you guys here for today. But I think what's going to be super fun is we're going to continue on this demo, and then what I want to do is eventually have like half the crowd be bad agents and half the crowd be good agents, and the bad agents have to go and basically try to hack everybody else's good agents that are trying to negotiate real good calendar invites. So I think that'll be a super fun activity we'll all try to do together. So if anybody wants to go and work on this with us as a group, I think this would be a really fun area of exploration. And we'll figure out who can hack, like we'll get point systems and we'll figure out, hey, like we can actually break the calendar invites and break your agent's calendar negotiation. And you have to encode, it's a game, basically. But this is a really good use case to see how good we can get these. And that's it.